Hello viewers, welcome to my channel. In today's video, we are going to see about rules of inference for propositional calculus. The main function of logic is to provide rules of inference or principle of reasoning. The theory associated with rules, we call it as inference theory because it is concerned with deriving conclusion from given set of premises, or we call it as hypothesis, or we call it as set of premises. The rules which we are using for deriving a proof from the given theorem is as follows. The first rule is, suppose if P is true, then P or Q is true. That is, P is a premise, P or Q is a premise. This law we call it as an addition law. Then P and Q is true, then P is true. This we call it as simplification. Similarly, if P and Q is true, then Q is true. This is also called simplification. If P is true, P to Q is true, that implies Q is true. This is, we call it as modus ponens. This law, we are using it very often. Then next rule, we call it as P to Q, that is equivalent to negation P or Q. This is an equivalence, which this also we are using often in theorems. P to Q is true, then negation Q to negation P is true. This is P to Q, that is equivalent to negation Q to negation P. This law we call it as contrapositive law. P to Q is true, Q to R is true. This is equivalent to P or R. This we call it as chain rule. Next, we see about direct proof. The implication of X implies Y. That is, if X is true, then Y must be true. The important rule which is used for rules of inference, that is to derive a theorem from the given set of premises. The first rule we are going to apply is rule P, that is, a premise can be introduced at any point of derivation. Second rule we call it as a formula can be introduced if it is tautologically implied by previous step in the derivation. So these two rules are very important while solving the inference theory. Now I am going to prove the theorems. First theorem says that prove that R or S follows logically from the premises. That is, C or D, this is given premise. C or D to negation H is a premise. Negation H to A and negation B is a premise. A and negation B to R or S is a premise. From this, using all the premises, we are going to prove that R or S is true. Step number 1, that is about description, is we are using C or D to negation H, which is a given premise. That is justification. Second step, C or D, this is also a given premise. Then I can combine step number 1 and step number 2, and using the rule modus ponens, I get negation H is true. And then given negation H to A and B is A and negation B is a premise. Step number 5 from rule number 3, step number 3 and step number 4, we get A and negation B using modus ponens. A and negation B to R or S, this is a given premise. Step number 7 is we are getting it from step number 5 and step number 6 using modus ponens, we get R or S, which is a conclusion. Hence the theorem. Next one, show that R and P or Q is a valid conclusion from the premises P or Q, Q to R, P to M and negation M. How we are going to prove the theorem? Let us see. step number 1, P or Q I am taking. This is a given premise. Step number 2, Q to R. This is again a given premise. And then step number 1 can be rewritten as negation P to Q, which is an equivalence. Next one, step number 4, we are getting it from step number 2 and step number 3 by using chain rule. And then step number 5 is P to M, which is a given premise. And for step number 6, we are taking contrapositive, that is negation M to negation P. This is P to M. P to M, this is a given premise. Then negation M to negation P. This you call it as contrapositive. Then negation M, this is a given premise. Given premise. This is a given premise. Now, here I am using negation M true, negation M to negation P true. Then using modus ponens, I get negation P is true. Here, negation P is true and negation P to R is true. This gives R is true, but by means of again modus ponens. Then R is true statement, and first step says that P or Q is again a true statement. Then we combine R and P or Q, which is a true statement, that is which we want to derive. This is a second problem. Now we pass on to third problem, that is prove that S or R logically follows from P or Q to P or R and Q to S. That is given P or Q, P to R and Q to S. Now we have to prove that S or R is logically true. Now I take first step as P or Q is a first step, which is true statement P. Then from step number 1, I get negation P to Q, which is an equivalence. Then step number Q to R, that is Q to S, this is a given premise. Here I am taking. Here negation P to Q and Q to S, that is negation P to S. This is by means of chain rule. Then negation P to S. P to R, this is a given premise. Now for this statement P to R, I take contrapositive, which gives negation R to negation P. This is a contrapositive statement. Negation R to negation P to S. Then I can use the chain rule for step number 6 and step number 4, which gives negation R to S. Negation R to S is equivalent to R or S. Next theorem, that is show that P to Q to negation R, which implies R, again one more premise, P or J and S, which implies J and S is a true premise. So using P to Q to negation R, P or J and S, then we derive J and S is true. Here step number 1, P to Q, this is a given premise, and Q to negation R, again a given premise. Now I can combine step number 1 and step number 2 by means of chain rule. Then I get P to negation R. Now R to negation P is, we are getting it from step number 3 by applying contrapositive statement. Here R is a given premise. It's given. Next, R is true. R is true and R2 negation P is true. Now we apply modus ponens for step number 4 and step number 5. It gives negation P is true statement by applying modus ponens. Now it's a given P or J and S is a true statement. That is a given premise. So this is given. Now I rewrite it as negation P to J and S by equivalence of 7. So we know negation P is true. Negation P to J and S is true. Then J and S is true. That means these all are the given premises. Now I am able to derive J and S is also true statement. Thank you.